Okay, so we're here today to talk about standards. Alan, are we good? Is the screen okay?
I can see everything, Peter. Yep, absolutely.
Fantastic. So we're here to talk about standards today. And as always, we're going to take a couple minutes here to get through some of the usual stuff. So we're thanking our members, of course. Without them, we couldn't produce this great content for you all. So we're thankful for them. We have a great website, and you've all used it a little bit at least to sign up for these webinars. But please know that there are case studies available there. There are resources that Jim will talk about today. So the website is a great resource for you all to use. Hey, Jay Hicks, can you come on? Can you come on and say hello to our audience? We're also thankful for guys like you today.
Yes, Peter.
All right. I don't see your face. There we go. So Jay Hicks, you are with Fortiline.
Yes, sir.
Yeah, tell us a little bit about what you do for Fortiline and what Fortiline does for the market.
Well, thank you, Peter, for having us. I'm Jay Hicks. I'm with Borderline Waterworks. I'm a 25-year industry veteran in the waterworks and PVF industry. As a whole, we are now launching 3 strategically placed HDPE fusion services locations in the southern United States, includes Texas, Florida, and North Carolina. My focus will be overall estimating and reviewing plans and specs, along with working with any municipalities that need help updating specifications with the 4710s and whatnot, and make sure everybody's all set and know what they're getting and make sure everything goes right for them.
Yeah, well, I've worked with you for years, Jay, and I know you're a real talented expert on polyethylene. You also work with a guy that I have a lot of respect for, Dennis Barnett.
Yes, sir. We got Dennis Barnett there in North Carolina. He travels the United States as well, doing a lot of fusion trainings and overall using his knowledge and background in HDPE to help our customers. And he doesn't get a chance to sit still very often.
No, he doesn't, but he's a talent for sure. So Jay, if we have a chance to use your expertise during the talk, we will. So please stay close. And if you hear Jim Johnston call on you, please go video on.
Will do. Thank you, guys.
All right. Good work. All right. We're going to share that screen again and get back to it. All right. So also social media, got over 15,000 followers on social media. It's tough to keep up with this on a daily basis, but you know what? We have a lot of fun doing it. We've got a lot of great content that we share, and we're even on Instagram now, believe it or not. Hard to believe. So on this website, you can see a list of all our members. We ask you to support the members of the Alliance for PE Pipe, those companies like Jay Hicks at Fortiline. Those case studies, I need help writing these case studies. Give me some content. We'll get some more in there. And now a plug for future shows. Our good friend Alan Abler is going to be on the same channel 24 hours from today to talk about that engineers package. We got a couple hundred people signed up for that, just like today. That's exciting. You know what? This stuff really isn't the most exciting stuff to talk about, but we're glad that you're committed to listening because it's so fundamental to appreciating and understanding this great product known as polyethylene pipe. Then on the 11th of May, we're going to talk about the various installation methods with lots of videos and lots of experts. Then we're going to talk about, we haven't done this one in a year, but we're going to compare our product to the other 2 leading products, PVC and ductile iron. This is an excellent segment taught by Dusty Langston on the PVC side, and our good friend Harvey Svetlik will talk about ductile iron. Then my team is going to head off to Shawnee, Oklahoma. So that's a suburb of Oklahoma City. And we're going to spend 75 minutes with leaders in the electrofusion and specialty fitting market, George Fisher Central Plastics. Very excited about that session. So be sure to sign up at pepipe.org. That engineers package, you got to send us an email and say, hey, send me the engineers package, and we'll send you a link so that you can download all the various PDFs for that. Poly Podcast, got to listen. We're going to drop another one next week on the marine applications of polyethylene pipe. Very excited about that. You're wondering who is on the call today? Well, there are representatives of municipalities, municipal water and wastewater organizations in all of these cities throughout North America, and we even down into the Caribbean with Bermuda. So Bermuda is committing fully to polyethylene on water and wastewater. very excited to get our first country commitment in that regard. New Rochelle, New York, Oak Lawn, Illinois. Who knew Chicago would even move toward polyethylene? Very excited about all the cities and the people that are committed to learning more about this great product. Now, Jim Johnston and Dustin Langston, would you guys come on and say hello to our audience? Jim Johnston, are you there? All right, Jim and Dusty. Jim, you are muted. Dusty, tell us a little bit about who you are and what you do.
My name is Dustin Langston with WL Plastics. I'm the VP of Engineering and Quality Assurance. I've been with WL Plastics for 16 years now. And today I'm coming to you from Rapid City, South Dakota, usually based out of Utah, but I'm up here in South Dakota today.
Awesome. Well, welcome back to the webinar program. You've been a long time, at least a year and a half, but you've been a teacher in many Alliance programs for quite a long time.
Yep, but I look forward to the upcoming PVC presentation. It's going to be a good one.
Yeah, thank you for the time on that. And Jim Johnston, tell us a little bit about yourself.
Well, I am VP and Chief Technology here at McElroy Manufacturing. I've been here, this is actually my 27th year now. So been around the polyethylene, fusible plastic, thermoplastic world for a long time. Nearly as long as Dustin's been alive. So.
Well, your role, not only are you the VP of Engineering and Innovation and Research at McElroy, Jim, you played a central role in the advancement of polyethylene through the various standard organizations, and we're lucky to have you today. And I really look forward to listening to this talk again. I've listened to it once before, and I learned something new every time. So without further ado, Jim, I've enabled screen sharing. So before I sign off here and mess something up, let's make sure that you can, in fact, do that. Can you take over? There we go.
You see my screen?
Yes, sir, I do. Alan, is everything cool?
You guys are ready to go.
Okay, so before Jim gets started, I just want to say, remember, if you get off the call early, we have 75 minutes planned for this. So we'll end at 15 minutes past the hour. Could be a couple minutes earlier. You can send an email to me, pdyke@pepipe.org, and I will see that you get your PDH or CEUs. Same goes for if you want a copy of that engineer's package. Any other questions, want to help with a project, a spec, you let me know, or send an email to Jay Hicks as well. Take it away, Jim Johnston.
All right. Well, again, Peter, thank you for having me on here. This is a little bit of a dry topic, but we're going to try and make it a little bit fun. Again, my name is Jim Johnston. I am the Vice President and Chief Technology Officer here at McElroy, and Dustin Langston is the VP of Engineering at WL Plastics. And I will just put in a plug that he is one of my favorite people in the world, and I appreciate him being on here with me. We're going to dive into standards, and again, somewhat of a dry topic, but we're gonna try and give you some good information to go forward with. So first thing I want to do is get something to work. So why do we talk about standards? Standards give us consistency and quality. They give us the safety. They give us ability to reference and do things and give us compliance and reliability. So without a standard, we don't know what we're doing and how we do it. So whether we're spec writing, whether we're putting in new systems, whether we're doing whatever that may be, having a standard as a reference gives you that ongoing capability. And it helps us answer a lot of the questions around design, training, installation, testing, maintenance, and repair. And we're going to touch on a lot of those topics today. Now, there are standards and topics that are beyond the scope of any 75-minute presentation. And we're really going to scratch the surface today, but I think we have picked out some of the really critical standards for us to focus on and talk about throughout the process. If you have questions, please type them into the question box, and we'll be answering those as we go. So again, the topics we cover today are not all of the standards out there to be considered, but they're a strong basis for the standards you need to know. I'm also going to focus on the fact that there are some essential standards and they are always changing. So I'm going to highlight some of that as we go through the day today. We're going to talk about standards from AWWA, ASTM, NSF, PPI, CSA, and really a number of other organizations. So many of these organizations, I'm going to put in a plug here, not only for the Alliance to join the Alliance and be able to get some information like you're seeing today. Peter will come back on at the end and talk a little bit more about membership, and it's free to those that are interested in this environment. If you're an organization, if you are a company that sells product, there is a free fee to that, but there's an opportunity. So for the standards organizations, most all of them, if not all of them, are available either as an individual membership or an organizational membership. And that gives you the ability to be part of the standards making process, get updates on the activities of those standards organizations, and it can give you a reduced cost access to the standards. For example, membership in ASTM is only $75. It gives you free access to all of the standards within the division that you join. It gives you discounts to other publications, and it gives you a lot of information. So I'm going to jump in here with one of the newest standard updates, and this one being from AWWA. This first item is the M55 PE pipe design and installation manual. Now, I imagine that most everybody on this call, or a lot of you on this call, have this exact book on your desk, this blue book. Now, for the last, gosh, Dustin, what's it been, 2 years now, we've been talking about the update upcoming.
Right.
But it's finally been published, and the new edition is out there, and that is second edition. It was published in 2020. It's been available on the website since 2020. You can order a hard copy version, or you can order an electronic version. This version supplements C901 and C906 and provides design recommendations as it relates to the use of PE pipe in potable water systems. And I'm sorry for whoever you are on the call, I'll say potable and potable intermittently here to keep everybody off their toes. So let's talk about this latest revision. Overall, M55 gives you some great resources, gives you great reference material for hydraulics and pressure ratings, the materials themselves, load design, heat fusion, mechanical joining, fittings, handling and storage, testing, and even maintenance and repair. So it's a great reference tool among a large set of tools that are available to you. The newest edition is authored by the AWWA committee. It included people that are HDPE end users, PPI members and staff, and MAB members, Municipal Advisory Board members. So this update included C901 and C906 updates. And we're going to talk a little bit more about those here in a few slides. It covers PE 4710. So this was really a major update to bring PE 4710 into this manual and get that advantages of those modern materials into this product. It includes a new section on disinfectant residuals. That is a hot topic, and we're going to touch that one a little bit further here. It includes updated definitions of design factor, hydrostatic design basis, hydrostatic design stress, pressure class, and surge pressures. So it also adds an average flow velocity for recurring surge. And that's for those of you that are wanting this reference will be available at 6.7 feet per second. For occasional surge, that's 11.6 feet per second. Again, it defines all of these pieces. It also gives reference to design calculators that are available for you to go in and update information. That includes PPI PACE, HDPE app, and PPI Borate. Dustin, do you want to add anything about any of those design tools, those calculators?
Yeah, absolutely. So along with the references to those apps, We have an entire chapter now dedicated to trenchless technology and trenchless installation of HDPE pipe. So not only can you reference the new chapter for how to install trenchlessly, but then you can also go onto the PPI website and look at PPI bore rate, for example, that will calculate mud pressures for you. It'll calculate pullback strength. It'll calculate and even give recommendations on DR for those applications. So it's a great
And
calculator.
how much do those calculators cost on PPI?
Oh, they are a ton of money. Very, very expensive. They are free. They are free for everyone to use. So you can go on the website, access them for free, and you can use them anytime you want. So PPI Pace is a great software to be able to compare HDPE pipe versus PVC pipe versus ductile iron pipe for your exact flow scenario to see what's going to have the best fit and what's going to have the longest service life. And then the HDPE app has a ton of calculations in it for pressure ratings, flow velocities, surge analysis, burial loads. Really a great calculator, great resource for everybody.
So I'd like to add, guys, I mean, Jim, I love the fact that you put this first because I consider this to be probably the most important reference available, except maybe the PE pipe handbook that PPI put out years ago. The only problem with this one, Jim, is it's $100. But honestly, if you're going to design with polyethylene, you need this thing. It's got a lot of
this is the Bible.
Yeah, I mean, to Dusty's point, it's got a lot of good cases in there too, examples of things. Anyway, good work.
Thanks, Peter. And so to continue to that, this new edition includes a complete rewrite of chapters 5 and 8. Chapter 5 covers external loads. Chapter 8 is conforming with D2774 on installation. I'm going to have Dusty talk a little bit more about that one here in just a few minutes. It replaced the design window, and that becomes basic installation and engineered installations. Updated soil class, modulus information, section on flowable fill, trenchless technologies, revised and rewrote the entire chapter on joining and fittings, updated the chapter on repairs for PPI MAB4, and that's another document that we're going to cover here in just a few minutes. Again, that's free. And while Dustin was talking, I checked. Free is also free in Canadian dollars. I checked the conversion, and it is also free. And lastly, one of the major changes that you'll find in the document, Peter touched on this, is a whole new set of appendix. The model specs per MAB3, added seismic applications and some case studies specific to earthquake applications, an entire section on marine installations, and a full set of case studies. 23 case studies are included in the new N55 manual. And it includes a full appendix on that PE 4710 pipe data, all of the specific information. So, Dustin, the basis for all of this discussion that we've been doing is the pipe itself. And what I'd like to do is jump over to ASTM and talk about the material specification itself, and that being D3350. You want to?
Absolutely. So there's a big misconception of what ASTM D3350 actually is. We often have it referenced on specifications that come across our desk that say, hey, do you meet the requirements of D3350 as a pipe manufacturer? And the answer is no, we don't, because this is not a pipe manufacturing spec. And that's where it's often misconstrued with how it's put into a specification as a pipe standard. This is a material standard. So this is required for testing of the resin itself when companies like Dow Chemical, Chevron Phillips, LyondellBasell, and INEOS, when they go and make a PE 4710 material that will then be converted into pipe by a manufacturer like myself, or maybe someone like George Fisher that makes fittings, then we say that the material we're using meets the requirements of D3350. Another one you might hear referenced is D1248. 1248 does not cover pressure pipe. It actually has not been used for pressure pipe since like 1985, but you will see this referenced in specs all the time. You will constantly see this standard referenced. It has been completely replaced for pressure pipe applications by ASTM D3350. So if you are selling a PE 4710 pipe into the market today, it is made from a material that meets the requirements of D3350.
So Dusty, are you asking our engineers in the audience to, in addition to mentioning 4710 for the pipe, that they should also be listing 3350-14?
Absolutely. So the way we see it done now with a properly written spec, it will say PE 4710 with a cell classification of 445574C, which we'll get into later what all that means. And actually, well, right there in front of us, it's the density, it's the melt index, the flexural modulus, the tensile strength of the material. All of those are classified into a number range. And with a number range specified, you have the cell classification for a PE 4710, which again, you don't have to remember it off the top of your head, but it is 445574C. So you'll have in your spec D3350 cell classification for 4710, and that is how you properly reference HDPE pipe in your spec going forward.
And I think the other one that's important here is that's how we want to go forward. But like you said, D1248 is still referenced in a lot of documents because it just gets copied forward.
Yep.
This would be one to look at if you're looking at your specs to make sure that you're not including D1248 and get it out of your process. It is essentially a conduit standard for wire and cable.
Yep, that is correct.
Okay. Now, one of the things I'm going to talk about is just like M55, there was a standard change that happened there. This does have a pending work item on it, and so there will be a change. Right now, the ASTM standard uses this designation, D3350-14, meaning that was the last year that it was published, was the 14. There is a work item open to adjust this one right now. And this one is just adding some more information to the system. There's actually two standards or two pending work items here. So you might be watching to see that a D3350-21 gets published. In almost all applications, it is best to use the most recent version because it's going to have the best data, the most up-to-date information, and have the primary pieces that we really want to talk about in there. So watch your standards, watch for those changes. Join the standards organization so you can get notified about the changes. That's a great way to get notified about those changes. Now in M55, we talked a little bit about oxidative resistance. There is oxidative resistance in D3350, and we get some questions often throughout this world about oxidative resistance. There is a specific standard that covers this. That is F2263-14. Now, this is the test method for determining the long-term oxidative resistance chlorinated cold water. And it is the basis for the D3350 section 6.8 oxidative resistance classification. It's referenced in two PPI documents that really help you further understand the testing and chlorine resistance that are out there. Again, PPI documents are all free. Those two documents that are out there are TN43 and TN44. They go into the oxidative resistance of HDPE to chlorine specifically. TN43 was really only intended to categorize the PE compounds. And basically there's three categorizations: CC1, which is the lowest, CC2, which is the middle range, and CC3, which is the highest, most resistant to oxidative chlorine resistance. And that's going to be important as we go forward. You'll hear that CC3 being sort of the default standard as we move forward through a lot of the standards we talk about.
You know, guys, specifically, I think on this one, Dusty, in that main presentation, we were criticized as having to upgrade our resin and evolve the product over time. And a lot of what Jim's just been talking about is evidence of the evolution of the product. Can you explain a little bit why, CC3, which I think all our pipe now for potable water is CC3, what does that represent? Why did we do it? And why is it when our competitors say our product doesn't hold up to chlorine, is that not the case?
Yeah, absolutely. And I wanted to do this as a roundup after Jim was done going through all the individual standards when it comes to chlorine resistance, because there really has been a lot of work done over the last 5 years in this regard. So it all started with some pipe in very hot climates, usually well over 100-degree water temperatures, that were seeing premature failures in the 15 to 25-year range. And again, this was 1% of the population of North America that was experiencing these types of failures. But it really took us back to the drawing board on, hey, how do we make sure that this never happens again? So I actually see a question come up, what's the allowed dosage permitted for HDPE pipes? That's actually the same allowed for all pipe materials. The EPA comes out and says that you have a maximum of 4 parts per million chlorine in a potable water line. So that is the same for HDPE pipe as well. And so we went to the drawing board and said, hey, how do we ensure that we never have a chlorine failure with polyethylene pipe going forward? And so we came up with a testing methodology that actually meets real world criteria. And then we came up with the CC1, CC2, and CC3 requirements for chlorine resistance. And along with that came the documents TN43 for small diameter pipe, and also TN44 for large diameter pipe. These actually correlate with C901 for small diameter and AWA C906 for large diameter. So the highest quality or highest grade for chlorine resistance is a CC3. And when we developed the test, there were a couple, there was maybe 3 or 4 manufacturers that could meet that requirement. But over the last 3 years, like Peter said, every pipe material now meets a CC3. And so if you get, for example, a C901 small diameter tubing pipe, it is guaranteed to be made with AWA with CC3 materials as required by AWA C901. So all of this, it sounds very complex how all these standards kind of cover each other. But what it comes down to is we have the criteria for chlorine resistance, and it has worked its way into every single standard now. And it will soon be added to the ASTM standards that meet up with C901 and C906 as well. So that's ongoing work, and we'll probably touch on that here coming up. But again, chlorine, it's still a PE 4710. It still has all the physical properties of a 4710 pipe, but where it has gotten better is in its oxidative resistance to make sure that chlorine isn't an issue going forward.
Yeah, and I think that's a great point, Dusty, because the industry has adopted the CC3 and gone to that. The standards, and we'll touch this in just a minute, the standards actually are continuing to evolve to say CC3, but the industry has already adopted that CC3 for potable water. So, okay, so TN44, Dusty talked about that one, covers resistance to chlorine, the pipe disinfectant index, calculation examples, again, great reference tools here. So C906, C901, let's go back to AWWA and talk about those two pieces. C901 covers piping 1/2 inch through 3 inch for water surface, and C906 covers 4 inch through 65 inch for waterworks. Now, both address piping and tubing and cover the dimensions, the pressure class, all of that information. They do both have actions pending. So again, updated information. C901 was last updated in 2017. It's being updated to allow only that CC3 rated pipe. Again, the industry has already adopted that. So in general terms, if you go out there, you ask for pipe, you're going to get CC3. C901's just now catching up. It currently allows CC2 and 3, but it's being changed to only allow CC3. C906 is also being updated. Now, it was updated in 2015, and its cycle, all the standards go through a cycle, and they'll be updated on an ongoing basis. That revision cycle has begun, and it's going to also include that CC3 with some other changes that are out there. So I mentioned C901, C906. We talked about the Canadians a little bit. Let's look at Canada. The major standard category for thermoplastic pipe up in Canada is B137, CSA B137. That standard did have a revision, so it's B137.1 colon, in this case 20, meaning it was updated in 2020. That was updated to add a new pressure class, or what they called Series 250 pipe and tubing. So this was really an update to show another class of piping material out there. But if you are on this call and use CSA standards, make sure you're following that current update. Again, these are constantly evolving. And some of the pieces I'm going to touch are things we've talked about in the past, but they've all got changes. Next, we're going to jump to NSF. Dusty, you deal with NSF quite a bit. I'm going to let you kind of touch these two. The two big standards here are NSF 14 and NSF 61.
Yep. So if you don't mind, can we actually skip over to NSF 61 first? Perfect. So NSF 61, and the reason I asked that is because NSF 14 includes NSF 61. So I just want to start with that first.
Yep.
NSF 61 is the potable water drinking standard. So it doesn't matter if it's a valve, it doesn't matter if it's a rubber gasket, HDPE pipe, any other piping material. All of these different materials that go into a potable water piping system have to meet NSF 61 requirements. So if you have an NSF 61 stamp on a pipe, that means that it has been tested, and it's annually tested. You actually send in samples every single year of your pipe from every single plant location that you manufacture at to make sure that you meet NSF 61. You also get audited twice a year to make sure that all the materials that you have incoming and outgoing are NSF certified. So it's a pretty extensive process to meet NSF 61 requirements. And again, every single HDPE pipe that's sold in potable water is NSF 61 certified.
The NSF, this is a health effects standard. This is not a performance standard, but rather,
yep.
what is this material transferring?
Exactly. Yep. And
to
that's
the water
what
itself.
it comes down to. And this also includes a lead-free portion, where it's a lead-free certification you can now obtain through NSF as well. And obviously all of HDPE pipe is a lead-free product. There's no lead derivatives inside of HDPE pipe. So now,
gentlemen, I'd like to interject here. We're blessed enough on this call to be able to have Paul Olson with AWWA with us, who is over some standards committees there. Yes, yeah. It's fantastic to see who joins our webinars. But you wanted to make sure that the correct date for C901-20 release was February 1st, 2021. So yes, they are proud of the release of that document and everyone's efforts that went into working hard to make sure that we had a more recent version of it. So, and I think some of us on this call also were a part of that process itself. So
yeah, thank you to Paul for that. Also, Dusty, could you also tell us about PPI's recommendation as it relates to DR on service tubing? We talked about it was updated C901. Please give us a little knowledge on that.
The update. So not only was the CC3 requirement for tubing sizes in C901 added, but we also have a requirement for DR9 for all pipe sizes. We got rid of the SIDR, which is inside diameter controlled, which was a DR7. That's gone. They removed that from. Come to find out, nobody in North America really makes that product anymore. So that was removed. But the addition of only DR9 being allowed to be sold for C901 tubing sizes going forward was also added. So, and that is correct. That was published in February. So thank you very much, Paul, and welcome to the call. Thanks for coming on, man.
Yeah, Paul, thank you. And I knew, and I couldn't find it as we updated this. I knew there had been one, and I just didn't find it as I was updating this. So I appreciate that. And again, that DR9 is specific to C901, the smaller size materials.
Yep, that is correct.
Half through 3.
And I keep seeing every once in a while questions coming up, and I'm sorry. Hopefully, we'll get those answered, and people are answering you as we go. But somebody had responded when I said 4 parts per million for allowable chlorine when it comes to EPA standards, and I saw somebody commented on there 4%. That is not correct. Make sure it is 4 parts per million. 4% chlorine will kill you. So don't drink 4% chlorine.
Yeah, big difference.
Big difference.
ppm and percent is a big difference.
Yep. So now going back to NSF 14, NSF 14 includes NSF 61. So that's part of it that comes along for the ride. You still have to meet all the requirements to make sure that the material itself is safe for potable water. But now we're going to go on to the performance side as well. And NSF 14 is going to audit the manufacturer to make sure that you are meeting all the AWWA and all of the ASTM standards that you're marking on your pipe. These become 4 audits a year. So you're getting audited quarterly by NSF. And they are watching you test the pipe. They are watching you measure the pipe. They are watching you do all the paperwork on inventory control. You know, it's really a very overall certification program. And so NSF 14 is not as common as NSF 61, but there's still a lot of manufacturers out there that meet NSF 14.
All right. So let's, we've been talking a little bit back and forth about Plastic Pipe Institute. I'm going to jump over to it. And the mission of the PPI is to advance the acceptance and use of plastic pipe systems through research, education, expertise, and advocacy. And Peter talked about this book, the PPI of Handbook of Polyethylene Pipe. This is another book that if you have the M55 manual on your desk, you probably have the PPI Handbook of Polyethylene Pipe. This handbook kind of covers all aspects of pipe design, construction, installation, maintenance. Now, you can order this from the website and get a hard copy version of it, or it is available off PPI as a free download of each individual chapter. So you can download all of the chapters or the individual chapters that you need. I'm not going to go in and read every one of these chapters just because of the time that we have available here. But you can see there's a whole variety of applications that are covered. And with that download option, you can just download the chapters that are relevant to your need. So next is another product that supplements the PPI handbook and the M55 manual. That's the PE Piping Systems Field Manual for municipal applications. This one is a little bit, I would say with the new M55 publication, really is kind of a secondary, but it's still a good manual. It covers an overview of piping systems, safety, storage of pipe, service lines and distribution piping. It also goes through leak testing, maintenance and repair, and all of these documents reference a variety of ASTM standards, and as well as PPI standards. With that, I'm going to jump back over to ASTM and talk about the installation, some steps within the installation. So we've talked about piping, how we design the system, what do we do? Now we have to start installing this process. First and foremost, we want to know that our operators that are installing these systems have been trained, know what they're doing, know how to do it. There's a standard out there relative to training, specifically for butt fusion standards, and that's F3190. And this is the operator qualification for piping systems. It covers both PE and polyamides. So if you're using any polyamides in your system, it's also covered with that. Your system, again, you want to know that you're installing systems that you have operators that understand how to install the system. It covers the training for butt fusion, saddle fusion, and socket fusion. So all heat fusions. It defines the minimum requirements for that fusion requirement. It has written and practical exams, defines the machine sizes. So if you are specific to a specific size of machine or type of equipment, what is covered, and if I'm trained on one, can I be covered by another size? It does require a test of the joint. So the person that's being trained has to test that their joint, that they actually can make a good joint. That can be a destructive or a non-destructive test. And then it defines the requirement of the organization and its instructors. So it's one thing to say, hey, I've got somebody that's been trained, but how were they trained? Who were they trained by? What does that mean? And it really gives you a basis if you're writing a spec and you want to make sure that you have somebody who is trained and knowledgeable. This is a good reference tool for that. So let's talk about the installation itself. Dustin, D2774 is the standard practice for installation. It has a brand new update to it. I think you might have been involved with this, weren't
I
you?
was. Well, as far as it's possible, when you have someone as awesome as Amster Howard heading the movement. So you heard earlier that AWWA M55 had a large update to its soil and burial requirements. And that update coincided with this update, which is D2774. And this applies to not only polyethylene pipe, this applies to PVC as well. We are looking at the soil envelope and how you bury a pressure pipe completely differently than we have before. And we're trying to make it consistent across the entire industry. So it doesn't matter if it's a steel pipe, a concrete pipe, a polyethylene pipe, a PVC pipe, they're all going to have the same terminology and the same requirements when it comes to soil burial. Things like Proctor, for example, or percent compaction. There were 2 or 3 different ways that you could quantify what that is and what percent Proctor is achievable for different types of materials. So all of that is being made more consistent with the work that Amster Howard is doing with soil and burial. And he is absolutely the #1 guy when it comes to this. He actually teaches courses at ASCE Pipelines on burial, and he is heading this work to make everything more consistent. So there's no more confusion. And that's the big update with this standard.
And again, you'll note that the date on that is 21, meaning it just updated this year. So it is a brand new document and some pretty significant updates in there. It's pretty exciting in the standards world. Exciting. That's kind of a definition we have to work on in the standards.
Yep.
So let's talk about joining the material. How do we put all this together? So heat fusion procedure, the standard here in North America is ASTM F2620. You'll notice that it has a -20 on it, meaning that it was updated just in November of this past year. Actually, it's just gotten a new update as well, but it's still a -20 is -20E. This standard covers socket, saddle, and butt fusion. Not a lot of socket fusion done in the water industry, but it does cover that, and there is some that happens from time to time. The current version, for those of you that are familiar with F2620, the procedure itself has not changed. However, there's a lot of documentation changes that are in there. It references PPI TR33 and TR41. Those were the technical reports of PPI that established the testing and were the testing that established the standard. So it added a section on the proper cutting and cleaning of pipes. So that was a piece that was missing, it's been missing for a while, really addressing when you cut it with a chainsaw, how do you clean the material? What do you not do? Added a reference to guided side bend testing, ASTM F3183, we'll talk about in a minute, for walls thicker than 1 inch. For this group on this call, that's going to be a lot of us. And it gives us visual inspection criteria. For those of you that are familiar with butt fusion, visual inspection has long been the standard. It's a good standard. It's not necessarily the best way to do it. And with the modern materials, the bead formation is a little bit different. So this changes the visual inspection really to focus on the gross errors and highlight some of the allowances there for the modern materials and what you can do to validate that you've done the procedure correctly. Remember that the bead itself is an artifact of the procedure rather than being specifically about the process. And then the latest update is specific to the natural gas distribution industry, but it's worth note. Some users within the natural gas distribution industry use a 500-degree heater temperature. This latest change updated that to include that process. So There's also another change coming, so I want everybody to be aware of this. There is a pending change on this one relative to the question of butt fusion of pipes with greater than 1 DR wall thickness. Really, the question of fusing any difference in DR wall thickness. The current standard just says go to your pipe manufacturer. We want to define that a little bit better. There's a project at PPI ongoing, and you should see a change on that one. I'm hoping relatively soon. Now I mentioned, go ahead, Peter.
Oh, I want to bring Jay on. Jim, I think 2620 is pretty important because we do a lot of training. I know McElroy does a lot of training, and I know that Jay Hicks has done training himself in the field, but I think Dennis Barnett, as one of the most prolific fusion techs in history here in the United States, has probably done a lot of training too. Jay, you still there?
Yes,
and I just wanted to confirm, Jay, that Fortiline does training. And when you guys go into an owner, a municipality, are you training to this standard?
Yes, Peter, we are. In fact, while I was up getting my training updated with Fortiline, I noticed that even the McElroy data logger updated to the F2620-20 while we were there. So we that update was nice to see. Gave us a chance to look into that. But yes, we provide training for whether it wanted to be an owner or an operator. We'd be more than happy to come out and make sure everybody's up with the latest standards, along with the greatest tools that are out there to make sure you're doing it right.
Yeah, well, 2620, Jim, I was just delighted to see that it was updated. A lot of really important items, particularly as it relates to cleaning, that I thought was great to see. And the fact that, Jim, your data logger even updates to that is pretty cool. But hopefully we'll learn a little bit more about that later. Jay,
we'll
thank you for coming on. And
Right.
Jim Johnston, back to you.
All right, thanks, Peter. Again, great comments, and I appreciate that because it really reinforces that use the current version of the standard that's available to you, because that current version is going to have the latest and greatest information that you use. And that's true whether you're talking about plastic pipe, whether you're talking about masks, whether you're talking about toilet paper rolls. There is an ASTM standard for pretty much everything that's out there. And probably your toilet paper roll, you want the latest and greatest technology there is out there. So that's a good thing to know. Keep your standards up to date. So I talked about testing for 1 inch wall thickness. The standard that is kind of the generic standard for testing in the field is what's called the bend back test. And that is just a simple coupon cut out of the pipe over the joint itself, and then it is bent back upon itself. F2620 says this is valid up to 1 inch, and that's essentially a practical standard. You try and do more than 1 inch thick, it's really hard to bend. It takes a big old boy to do it. It takes me and Dustin together to do it. So what do we do if it's greater than 1 inch? And prior to the standard, there wasn't much out there. Some of you may have seen some things out there in the world. This is an example. You may have even seen something like this. The guilty have been protected here in this picture. In general, don't do this. This is dangerous. These things are done, but it's the next picture in this series right here includes when they let go of that pipe and it cut the truck in half next to them. So it's not a pretty thing, and you want to make sure you're doing something in a safe and simple process. There is a standard out there that's F3183, and it is a guided side bend test. It is a very simple test. It's very similar to what's done in the steel industry today. The standard provides a method, gives you the coupon, the equipment, and the testing methodology for anything 1 inch and greater. And it's a simple infield tool. It looks a lot like this. Now, all standards, we talked about all those years that are on each one of these standards. ASTM's basis is a 5-year review process. And this standard, F3183, is going through a review right now.
Hey, Jim, thanks for showing that image of the guided side bend tool. last year we did 2 demo days at the Alliance. We had over 500 people attend those. This year, Jim, we're doing a demo day, and we're going to show, actually do this live like we do in our traditional road shows, Jim. But then we're going to have a second stage where we're going to show how to make the coupons. So for those people that want to learn more about this, sign up for demo day, watch us do a coupon bend, but then also watch us make one of these in the field. So we're going to actually cut it with a chainsaw, plane it, and prepare it to go into that McElroy side bend tester. That'll be on June 23rd. You can already sign up now at pepipe.org. Back to you.
All right, thanks, Peter. And that's the beauty of these kind of tests, whether it's a 1 inch or smaller, and you can do the bend back or do something like this, the guided side bend tool. It's something that you can do in the field if you want validation of a material. Now, it is obviously a destructive test. I have to cut the pipe open to do this. If you do 100% destructive tests, you will never finish your pipeline. So, well, what do we do if we don't want to destructively test all of our joints? How do we validate the quality for the system? You can data log or record the process itself and show that the procedure was correctly followed. There is an ASTM standard. Again, you're writing specs, you want things out there, whether it's what you do for your in-field testing, how you want your data recorded. There's a standard for how you record the data on the joint to show that the procedure was correctly followed. And that's ASTM F3124. This is a 15 version. That means it is also up for a review in this year. So it covers the data to be captured by recording devices for the heat fusion. It has to be able to capture the heater temperature, the pressures, all the stages for the process, the operator, the machine, the joint number, other information. So there's a lot of data that's available to you as a pipeline owner, whether that's you as a municipality, as a contractor. These are things that you can do to say, hey, I want to document every joint and show that it was done correctly. So date and time, equipment manufacturer, model, serial number, procedure that was used, and document the material. You can document the pipe, the OD, the material, the fittings, the components, and now you're building your GIS system directly from the field without sending out another crew to do it. Grab your geolocation, grab your materials, grab all your information directly off of that. So we covered heat fusion. Let's talk about electrofusion. This is standard F1290-19. Excuse me. F1290 covers socket and saddle fusion, covers the operator requirements, the equipment, and the procedure. And it gives you some really specific information about that joining. Now, it still has some more information, and there's a couple of different documents still going on with electrofusion right now. But to get real specific in the procedure and a generic process, PPI has published 2 installation guides. That's MAB1 and MAB2. That's Municipal Advisory Board at PPI. MAB1 covers the generic procedure for 12-inch and smaller electrofusion fittings on pipe, and MAB2 covers electrofusion for 14-inch through 20-inch pipe. There are some things that you have to do different in that larger diameter pipe. So now we have a system built, and how do we test it? The standard for testing is F2164, hydrostatic pressure testing. Dustin, I'm going to jump over to you and talk about these. I think you had a lot of experience both with this, and we're also going to talk about pneumatic here in a minute. This is the most common used.
And not only most common, but the most recommended.
Yes.
Whenever pressure testing a pipe system, you're putting a lot of pressure and a lot of energy into that piping system. When doing that with a pipe that's been full of water, doing a hydrostatic test, which is F2164, it requires a lot less energy than using a compressed air or a pneumatic test, which we'll get to next. If there is something that comes apart, maybe a bolted fitting or something that might come apart, the release in energy is much less with a hydrostatic test than with a pneumatic. So it's much safer. This is the one that we all recommend as far as pipe manufacturers go. All the fitting manufacturers, we recommend this test. F2164 it does not allow leakage at all. You know, there's a 0% leakage that's allowed during pressure testing. The process of that test is to bring it to fill it full of water, bleed out all the air that you can, and then you start increasing the pressure. As you increase the pressure, you take into account what time of day it is, if the pipe is buried or if it's above ground. If it's above ground and it's in the middle of the summer, you're going to reduce the amount of pressure you're going to put on the pipe due to the high pipe temperatures during, you know, middle of the summer. You know, pipe temperatures can easily get over 100 degrees Fahrenheit, and that needs to be taken into consideration. And of course, there's notes in this standard on how to do that. So you bring it up to pressure. You'll actually take it a little over your test pressure to make sure everything has been fully expanded, the pipe is moving, you know, if it's being tested above ground. And
hey guys, I'm losing Dusty, Jim. Could you take over for him? And I just want to mention to our audience, we've had a lot of people come on the call here since we started. This show is going to last for 15 more minutes. We are on time. So we're going to certainly be done by a quarter after the hour, and there's still a lot of very good slides to go. So please take over. Dusty, sorry about that, but your bandwidth was going away.
Yeah. So
thank
again,
you very much. Am I good now though? Okay. Yeah. So I just want to finish off by saying that this is a zero pressure loss, or sorry, zero pressure loss, a zero water loss test. If you have any leakage at all, that is a failure for a polyethylene pipe system. Next slide.
So let me start with this one again and just reinforce that this is the preferred method. It is the safest method. It is the recommended method. And we're going to show the next one because the question does come up. And it is a good reference because there is a standard. And if you did this without a standard, you'd really be in trouble. But
so before you go to the next one, Jim, before you go to the next one, can I just ask, Dusty, I've had people complain that they have to add makeup water to polyethylene and it's an evidence of a leak. Can you just give us a brief explanation? I know it's not part of this talk, but can you just give us a brief explanation on why the need for makeup water?
Yep. And so that's actually what I talked about when I mentioned how you overpressurize from your test pressure. Let's take a DR11, for example. A DR11 has a maximum test pressure allowed at 80 degrees or less of 300 PSI. When you're bringing the pipe up to pressure, the pipe is expanding slightly circumferentially from the pressure. And so that slight expansion is what people are referencing when they say, well, I had to add makeup water. No. You didn't add makeup water. The pipe expanded as you pressurized. And that's the reason you had to put more water into the pipe. And so that's why when I said, hey, you need to go 5 PSI, 10 PSI over your test pressure, initially, that's what I'm taking into account is, hey, we're going to overexpand this pipe by 10 PSI. And then when you release that 10 PSI down to the test pressure, all of the expansion has taken place. So there's no more makeup water being added at all. And at that time, you start your timer, and that's when the test starts. And
it's clearly shown that you're not leaking water at that point.
Exactly.
The pressure doesn't fall any further.
And if you actually read the standard, you'll never ask the question on why did I have to add makeup water here? That's not what you're doing. You're adding water for initial expansion, but once you actually switch over to test pressure, expansion is done and you need to add no more water.
Great, thank you.
All right, so jumping forward, the pneumatic test, F2786.
Also known as the scariest pipe standard in the world. Not really. So most of the time, they're using this for low pressure applications. So we're talking maybe 20 PSI of air pressure. But I have literally
inch pounds.
Thank you. But I've literally been on job sites where we have air tested at 300 PSI. Luckily we've never had a failure ever. So I've never had an issue, But if you had 300 PSI released quickly, that would be just a bomb going off. You know, it's incredibly dangerous. And there are some requirements when it comes to this for safety reasons. The pipe does have to be buried. You cannot have you cannot have this pipe exposed or above ground to air test it unless it's very low pressure. So you definitely want to test this below ground.
Okay.
But the
So,
procedure
time
itself
now.
is the exact same.
Yep. Time now for a pop quiz. Dustin, what is the most common question or pushback we get against HDPE?
Oh. I guess it really depends on the part of the country the question's coming about. How to repair. I was going to go with hydrocarbon permeation, but repair is a good one. How do you repair it? Well, it's not going to break. You don't need to repair it. That was our.
Yeah, so that's one thing. But we also know that the most damage occurs from somebody else. It's third party damage. So Plastic Pipe Institute Municipal Advisory Board has a document that really helps address this, and it is really a great document. It's called MAB4. It's the basic repair HDPE options. And it gives you the tools to answer those questions relative to repair. The publication is available free to download from the PPI website. You can order printed documents that are printed on Tyvek material. So those are available, but a free download is out there. MAB4, as are all documents, is free, takes you through the steps: decision, fusion through mechanical repair. If you're unable to eliminate water through the pipe, then fusion should be if you are able to eliminate water, then fusion should always be your first choice. Squeeze off tools can create dry conditions for fusion. We're going to talk about that here in just a minute, squeeze off tools specifically. All mechanical coupling should include pull-out resistance restraint to be used with external restraint clamps, internal stiffeners where applicable for those mechanical couplings. Corrosion protection should be provided for all underground fittings, and fab fittings should always have at least 1 DR thicker than the connecting pipe and have the same rating as the pressure of the pipeline itself. So illustrations, the MAB4 includes illustrations for repairing fabricated fittings and or molded fittings if they're applicable. So consult your mechanical connection supplier to verify that they're going to work with HDPE. Almost all of them will or have an option to do so. From there, the publication includes a whole series of flowchart decision trees. So it really makes it easy for you to do the repair situation. It's a great field manual to have in the field. Here's my situation. What do I do next? So fusion. If I'm going to do fusion, what are my options? Determine the leak type is where we're going to start. Whether it's punctured on one side, punctured on both sides, severed, mechanical fitting, whatever it may be, it gives me a flow through the process to reference and figure out where to go next. What's my next step in this process? It includes pictures and descriptions of how the fusion and mechanical fittings can be used. And if we're going to repair this material, we need to be able to stop the flow. So in the case where a valve is not available, there needs to be a solution to stop the water at the repair site. With HDPE, because it is a thermoplastic, it is a ductile material, we have that solution, and that's squeeze off. So what is squeeze off exactly? It is the ability to basically pinch off this tube. Think about a straw and just pinching that tube off. With a long history in the natural gas industry, there are already multiple standards for tools, procedures, and qualification of procedures. And there are a lot of tools out there. They are used widely throughout the water industry, throughout the natural gas industry, mining, oil and natural gas gathering side of the world. There's some really good stuff out there and some really good standards. There are 4 primary standards you need to know. And Dustin, I'm going to let you talk about these four, but just these are the four that I think are really the key highlights with
Hey guys,
squeeze off.
before we talk about the standard, a lot of times, Jim, you were the one that counseled me early on and I'd say, well, Jim, how do you fix this stuff? And you'd say, well, how do you fix ductile iron today? You put a band clamp on it. And that's what you tell your staff, right? Until you can figure out, what kind of failure it is. Right. So you just put a band clamp, take a Hymax band clamp, put it on there. And guess what? It's going to work just fine. And some of these products, Jim, are so good now that we consider them to be permanent fixes.
That's right. That's right. And that's the big thing with this is repair. There are some differences, but in general terms, when you're in an emergency situation, the repair is going to be the same way you do it with whatever system you have today. There's nothing special that you have to do, whether that be a band clamp, whether that be a valve install, whatever that may be. You have solutions already in your toolbox that will work with polyethylene for an emergency.
So Jim,
repair.
I interviewed an engineer with the city of Duluth for the podcast program. And I asked him, I said, so what kind of polyethylene? They've been using poly only. This guy's name is Eric Schaefer. He's a PE, Jim, and they've been using poly only for 15 years in their water system. And I said, so how many failures have you had? He said, we've had no ductile iron failures. Excuse me, we've had no butt fusion failures in any polyethylene line that's been installed. We early on in the early days, they had a couple saddle fusion, electrofusion failures because they weren't cleaning it properly. But now, Jim, in Duluth, they require any contractor to go through annual fusion training. So that's butt fusion and electrofusion. Yep. And for years, they haven't had any fusion failures at all in Duluth.
I think in a lot of ways, we joke about it, but the most common polyethylene pipe failure is a M5 bucket loader impact.
Right. Yeah, it's really pretty exciting. So thanks for covering.
You're on mute, Peter.
Going back.
So thanks for covering these in this standards talk. Great job.
Yeah, so going back to squeeze off, the existing standards, squeeze off was really started in natural gas distribution. And so a lot of these standards are geared towards natural gas. We're actually writing new standards to make it for water, potable water applications. But the biggest one that you're going to use as a reference today, if you perform squeeze off, is going to be PPI's TN54. That's technical note 54. And that's the guideline for squeeze off of pipe for water, oil, gas applications for everything. And that's going to be the real go-to procedure on squeeze off.
I'm going to call out one thing here. You see on ASTM F1563, there's a -01 and then a 2019 in parentheses afterwards. This is in reference to the fact that the last time this was updated was in 2001, but it has been reviewed and reapplied in 2019. So that means no changes were made since 01. So in this case, you know that F1563 has had no changes since 2001. Just as a quick reference. Again, those four standards, but PPI TN54 is really your go-to document here. And it gives you all the information that you need. The squeeze off tool manufacturers, there are a couple of members in the Alliance that are very active. They are great resources for how this process is done. Basically, the process is to squeeze this off at a prescribed feed rate on the pinch off, and then also on a prescribed release rate. But that pipe will come back to its original round. And you don't want to squeeze off again in the same place, but that pipe will do this without any damage going forward. And with that, Peter, I have a resource slide here. I'll put in a plug for the Alliance for PE Pipe. You can find a lot of the references for all of these different things, including documents and shows like today's show here on the pepipe.org website. ASTM, AWWA, CSA Group, NSF, the Plastic Pipe Institute. Again, everything on the Alliance and on the Plastic Pipe Institute website are free and free for download. So reach out to those as a great resource and a great opportunity. And with that, if we've got any questions, we can take some questions.
Yeah, we just got a good question saying, hey, Jim, does squeezing off affect the pressure rating of the pipe?
That is really a good question. No, it does not affect the pressure rating of the pipe.
Why not?
Because it does not damage the pipe in any way.
Right. So as long as you follow the prescribed, like on a 4-inch, it's 4 minutes on the squeeze and 8 minutes on the release. As long as you follow that rule, you're okay. In fact, PPI says you can squeeze off in the same spot multiple times, but most people do not. So what I've learned from guys like Dusty and Jim is that the practice in the gas industry is sign it, clean it, and sign it after you're done with the squeeze off. And then next time you want to squeeze off in that same general area because you never got around to putting a valve in, just put it a couple pipe diameters away next time and keep signing. And that way you're sure to never damage your pipe. That's kind of what I see as being the practice.
Yep. And for
not seeing any additional questions. Dusty, do you have anything else you'd like to say?
Yeah, I wanted to mention for squeeze off, there's really 2 scenarios that you're going to use it. The first scenario is if you want to make a repair on a line or maybe an add-in, a tie-in on a line. Where you can follow the procedure and make sure you do it exactly right. But then there's emergency scenarios where you might not have 10 minutes to squeeze it off nice and slowly. You want to shut water off immediately. And you can still use squeeze off in those situations, but you might squeeze it off faster than prescribed. And if that happens, you could experience stress whitening on the squeeze. And if that happens, when you release it, you would put a repair band clamp over that area to make sure you're not going to have a future issue with that section.
Good. Thank you. Thank you, Dusty. Great job today. Alan Ambler, anything else to add? Thank you for handling questions today.
Nope, no problem. Great to have everybody's questions. Municipal water systems aren't perfect. So sometimes our valves haven't been through the valve actuation plan that many Department of Environmental Qualities requires to. So that squeeze off tool for your guys that are in the field operating and maintaining these systems is actually more useful than one might think. So definitely good presentations here. Love to see all the people that are on within the standards community that have helped join us and contribute as well. So thank you guys very much for a great topic.
So Alan, we'll see you tomorrow. You're the lead on the engineers package, same time, same station. And a lot of this talk today, Dusty and Jim, on squeeze off footage makes great squeeze off tools. I'm sure Fortiline sells those. So you can get those, you can rent them or buy them. Jay Hicks, I want to say thank you to you for sponsoring today. Any final words?
No, great presentation. Everybody knows I take a vested interest in specifications. So if anybody has questions out in the field or whatnot, feel free to give us a shout. We have people that can help you out along with the Alliance and all everybody
so Jay,
here.
It's J.Hicks.
JAY.Hicks, HICKS at fortiline.com.
All right. I just sent everybody via chat your email address because I don't want to take people's time by pulling up a slide. Jay Hicks, Fortiline. Thank you very much. And Jim Johnston, great job putting this deck together today. Thank you very much, sir. Any final words?
Thanks, Peter. No, I appreciate the opportunity. It's a meaty topic, but we enjoy doing this. I think I saw a question of, is this going to be available?
Yeah, so thank you for reminding me to look at Q&A, Jim. It will be. It takes us a week or so, but we're going to put it up on YouTube. I think this is a pretty important talk, Jim. You kept everybody through 75 minutes, all but 1 people, 102 out of 101 people stayed. So congratulations. That, my friend, is a record.
Cheers to you.
All right, guys and gals, thank you so much for witnessing another Roadshow Light program at the Alliance for PE Pipe. We'll see a lot of you tomorrow. Dusty, something else you want to say other than goodbye?
I just turned off my video. See you guys
later. All right,
later.
everybody. So long. See you tomorrow.
Thanks, Peter.